Okay, let's discuss how we went about solving the Fermi problem today. So this is the Fermi problem. Estimate the total in pounds, LVS, trash from U.S. homes in 1 year. So this is the question. So there are some things we need to know. How many U.S. homes are there? So we might start with the population. Now let's again do an upper and lower bound. So I happen to know that the population is a bit more than 300 million. I know it's 317 million. But suppose you didn't. Suppose you only knew something. You knew that Maine had a population of 1 million. Or you knew that there were cities that had populations of millions. You should still be able to estimate a total population of more than 50 million. So this would be a lower bound. Now, what about the size of a household? How big is a household? Well, there are certainly people who live by themselves, and there are couples. So we need some estimate. So let's do a lower bound. So this would be our low column. This would be our high column, although that population is correct. So we might assume something like 2 people per home as a lower bound. This is a little unreasonable because many people have children. And as a high, maybe you could assume 4, you could assume 5, or whatever. I'll say 4 people. 5 is possible. 6 sounds unlikely as an average. So this can tell us how many households we have in the country. So if we have 50 million people and we have 2 people per household, then you'd have 25 million homes. And this one's a bit more work. 317 million divided by, or 317 divided by 4. Let's see, 317. I need my calculator. It's going to be 70 something. So 317 divided by 4. I get, I'm going to round down a little bit, 79 million households. Now, how much does a household produce trash-wise? Well, our experience is probably weekly, or you might take the trash out each day. Whatever works for you. Perhaps you take out the trash each day, and the trash weighs. Think about the weights that you've lifted, or think about anything that you know the weight of that you've lifted. It might be more than 5 pounds. Maybe there's 5 pounds. Per day on the lower end of things. And so 25 or 30 pounds a week. And maybe on the higher end of things, maybe it's, 15 pounds a day. If you're not sure, now how much does that daily trash bag weigh? So at 5 pounds a day, this tells you that it's 35 pounds per week. And over here, if it's 15 pounds a day, then it's going to be 70 plus 35, so 105 pounds per week. So let's, you can go several directions now. We could take and figure out how many pounds in a year, and then figure out things, or we could figure out how much each home does in a week. It doesn't matter. Let's do 35 pounds per week times 52 weeks, which is about a year, and 105 pounds a week times 52 weeks. So again, this is our low column. This is our high column. Let's figure that out. So 35 times 52 is 1,820 pounds per year. And 105 times 52 is 5,460 pounds per year. So, and this is still per household, the way I'm doing it. Okay, let's multiply the pounds per year per household by the number of households. In the low column, we have 25 million homes. So 25 million, 1, 2, 3, 1, 2, 3, times 1820. That gives me, my calculator gives me a number, or a set of symbols that looks like this. And so I'll explain that in a second. If I do the other multiplication, which is 79 million times 5,460, my calculator gives me this number. Whoops, it's an E. So if you're not familiar with what these things mean, we are going to talk about them in class. Let's talk about them just for a minute now. This symbol means times 10 to the 10th power. And this symbol means times 10 to the 11th power. So the 10 here is the power, and the 11 here is the power. Now, how do we make sense of this answer? Well, when you multiply by 10, remember you just move the decimal place. So this would be 4, 5, 5, and we're going to move the decimal place to the right 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You just put zeros there. And then over here we move it 11 times. So 4, 3, 1, 3. That decimal starts after the 4. We're going to multiply by 10 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we put those zeros. There's a quicker way of doing this we'll talk about in class. So what is this number? Let's separate out groups of 3. So here are the hundreds, thousands, millions, billions. So this is 45 billion, or 45.5 billion, or 45,500,000,000. And over here, what do we have? Groups of 3, groups of 3, groups of 3. This is 431 billion. Now, and we'll talk more about this, but this 3 doesn't really matter very much. This 3 is less than 1% of this answer. Right? It's less than 1%. So actually this 5 isn't very important either. It's barely a percent. So these are our two numbers. Notice they are within an order of magnitude of each other. And remember the actual answer from, I think it was the EPA, that's not actual, was about 500 billion. So this answer over here is quite close. This one is a tad small. And there are 2 reasons why this one's too small. So you would lose a point or 2 on that one. And so this is further. This is too far. That's too light of a color as well. That's too far away from an order of magnitude. So too far away. But that's because there were 2 problems here. One was assuming a population far too small, and assuming too small of an average household. So but only just barely. It's only just barely an order of magnitude away. So you can even make a couple errors or underestimates and come quite close. So I hope that helps for today. That's the end of that.